Okay, so you have a handful of different vocabulary words. We're going to get through it as we get through the lecture. This section is totally new. Okay, we're doing something totally different now. Looking at this equation, basically what we're doing is we're adding up the exponents. Okay? When I say adding up the exponents, now the bases don't matter. Okay, we can add a and b and x and y together. So we have negative 2a, 2b4. We're only focused on the exponents. 2 plus 4 is 6. That means the degree is 6. Any questions?
Wait.
So bases don't
Wait,
matter,
where's
it's
the
just the
A and B
exponents we're doing.
Correct.
Alright, okay, man. And that makes sense.
Easy peasy.
Okay, next one.
Peters, where's the A and B go?
I just pull them down here. I put the 2 and 4 and I add these together. Adding the exponents degrees, or what they are together, gives me the degree.
Oh,
So 4 plus 2 is 6.
okay.
So this is to the 6th degree, which we'll get to this in a minute.
Okay.
Okay, next one, 4. Anytime you see a number, it's not 1, it's to 0, okay? So if there is no number here, the degree is 0. It's just a constant, right?
Mm-hmm.
And that's what degree 0 is. It's a constant. Okay? Good. Okay, next one, 8y. There's imaginary 1 up there, at least to the value of 1. We don't know what it is, but the degree is 1. Pretty straightforward, right?
So if that is a variable, it's a 1?
Yes. See, there's no variable there, so we count it as 0. Okay, next one. Now we have multiple terms going on. We have 4x and minus, so we have 2 terms going on. So we're going to try to find the degree of the polynomial. So this first term, the x is 1, so the degree is 1. Then this next one, negative 18x, our degree is 5. Now, we do not add these together. We add these together. There's no operation in between them. So this is one term. Are we clear? Hang on a second. So now we have 2 terms and an operation in between it. We're picking the one that's the highest, not adding them all together. Are we clear? Okay. So this one's 1, this one 5, so our degree is 5. Are we clear? This number right here that's in front of the equation, we're going to get to into this further. This is what we call the leading coefficient. So leading coefficient in this case is 4, and this one is negative 2. It's the number that's in front, what it starts with. Okay? As long as something's in standard form, which we're going to cover when we get to the next side of the board. Okay, this one's decimals. Really doesn't matter. We're still looking for powers. We're looking for the highest degree. So we're x2, y, okay? This is like step 1. x2, y1. The degree is 3 in this case. Looking now at this one, x and y, the degree is 2, the 2 imaginary ones. Just a constant is 0, okay? So our highest degree is 3 in this case. Are we clear? Cool. Okay, next one. We're 6x4, degree is 4. 9x2, degree is 2. X, degree is 1. 3, degree is 0. The highest degree is 4, right? We're always picking out which one's the highest, ignore the rest of them, okay? Now, let me tell you what happens while we're doing this. When we go to classify something, bless you, we need to know the degree and we need to know amount of terms, and that's what tells us what the problem is. Okay, and we'll do a few of those together. Okay, standard form. You will use this for the rest of the class. What standard form is, it is highest to lowest when it comes to exponents, not numbers. Okay, so the highest degree to the lowest degree. So let's go through this problem. We have a term, subtraction, term, addition, term, subtraction. So we have 4 terms in here, okay? First term separates it. Second term separates it. Third term separates it. Understand? Now we're going to write the degrees of the exponents. So this x is 1. This is to the power of 3. This one's 0 because it's a number, and this is 2. Now that we have these, we can rewrite these, okay? We're going to write it 3, 2, 1, 0. So this becomes our first term. This becomes our second term, our third term, and our number. Now notice, you don't really have to do this as long as you put it in exponent order. What you don't want to get confused by, x3 plus y. That's not 3, that's 4. Okay?
Wait, say that again?
x3 plus y. Anytime you have dual variables within a term, you have to add those together. Okay? Make sense?
Yeah.
If you have two variables together in a term, which isn't the case here. Okay, so once again, we take these, we classify them, what degrees they are, and then we put them in descending order, which means greatest to smallest. Okay? After we do that, we can state what the leading coefficient is. This one had 3 exponents, the highest, so the leading coefficient is -4. Okay? Are we good?
Yeah.
Okay, let's move on to the next one. So we're y3, y5, y1. Okay? So this one has 3, this one has 5, this one has 1. So it's going to go 5, 3, 1. Okay? So 5, 3, 1, this is in standard form. Our leading coefficient is 1. Why is it 1? Right. It's always at least 1. What if this was negative y? It'd be -1. We just don't show the 1. Okay, let me see thumbs up or down on this. Is there any of this I need to go through again? Okay, which part?
And everything. Bad.
Okay, x, it's to 1 degree. For x3, it's to 3 degrees. That's just the number by itself. It's 0, x is 2. So these are the exponents.
So whenever
So the limit.
it's an exponent, it's just that's like a degree.
Yes,
Alright.
at whatever the highest one is. But typically, before we even start the problem, we need to put it in standard form. So that means descending order. Eric, can I get you on the side, please?
Yeah.
So we're going to put largest to greatest. Okay? Okay, let me see thumbs up or down on this. Okay, cool. Yeah, go.
Wait, how did you get 4? -4.
This right here. This one has the highest amount of exponents. So I take this and I put it for 3. This I put it for 2. This I put it for 1. This I put it for 0. Now, this should normally look like this. It should be highest exponents to smallest. 3, 2, 1, 0.
And then 4 is just the end.
Yep, whatever number is with the highest exponent is what the leading coefficient is.
Okay.
Okay, yes.
You were talking about when there's 2 variables in a term, you would add it. Can you give an example?
Okay, I don't have one on that one because that's going to be tomorrow. But essentially, let's say we had that. Let's say this one was 20xy. That would be 2. Okay, so that would be these two would be in line with each other. Okay. Now I will tell you typically that doesn't happen too often. It can, like right here. There's no addition in here, so the degree here is 6. The degree here is 6, but it's one term, which we're going to cover in a minute. So that means this is a monomial to the 6th degree, if I'm going to classify this.
Peter, why the b is equals 1?
Which one?
The b. B.
B?
Yeah.
Oh, well, the leading coefficient, we'll talk about that in a minute. We're not adding or subtracting here. We're looking at what the leading coefficient is, like -4. Okay? So looking at this one's 3, this one's 5, this one's 1, right? Okay, so we're going to put them in descending order. Which are not in descending order, we have to flip these two, right? So this becomes y to the 5th, y to 3, and 4y. What's in front of this y?
Nothing.
There's the leading coefficient.
Okay.
There's no math here, this is just labeling it. It's saying what is that first number in front of the highest exponent. And then standard form always goes from highest to lowest. Okay? You need to know this table. Okay, when you go to classify. Believe it or not, it's not hard, especially if you know Spanish. Because there's a little bit of a Spanish thing going on in here. Okay? So let's talk about it. We know what constants are, right? We covered that in Algebra 1. Those are numbers. Okay, so if it's a number by itself, we know it's 0. Okay? Mono means 1. Okay? So monomial means one term. That would be like 3, the number 3. It's 2, 0. It's only one term. There's no addition or subtraction. Is that clear? Okay, next one. Linear. That's what we did in Algebra 1, right? Straight lines. So linear means the degree is 1, and let me explain. Are we able to graph this out? Well, technically we are, but do you have the knowledge to graph this out yet? No, because you don't know what happens with variables that turn. That's what's called quadratic, when they flip around. You have x1 and then you have x2, and that's later. So we're not there yet, but linear was y equals mx plus b, right? There's nothing to the power of 2. That's what linear is, okay? So linear is to 1 degree, and then depending on how many terms there are. Quadratic. Quadratic is x2. That means you have 2 x's in a line. It's flipping around. That's what quadratic is. Cubic. We should know what that one is. Rubik's Cube. How many sides when we draw it in 2 dimensions do we see? Someone say 3. Because if this is a Rubik's Cube, right, we can see the three sides. Right? There's 3 sides to a cube. Or if I'm just doing it as a cube, we can see 3 sides. Okay? How many quarters are in a dollar?
4.
Good. What does this mean, Anna? The very first part of this word. Kind of. What's 5 in Spanish? So the QIN, QUR, remember that's quarter. QUI, N is 5. Everything after 5 doesn't matter. Now it's numbers. It's 6th, 7th, 8th, and so on. Nothing else changes. It's just whatever the degree is. There's no new words. Are we clear? So you need to memorize this. Constant you should know. Linear you should know. Let me tell you how we remember linear. When you guys were graphing lines, what direction were they? It was one line, it was straight, right? That's what a linear line is. So linear 1. Okay? Quadratic 2, the line's flipping around. Cubic, 3 sides. Quarter, 4 quarters in a dollar. 5 on the last one. Good with the degrees and the names?
Yes.
Okay. Terms. Terms are how many things we have going on. So if we're going to look at this one, we have it in standard form. Okay. The highest exponent is 3. So this is cubic. Okay. Now we're going to count the terms. 1, 2, 3, 4. There's 4 terms. That's a polynomial. So we go to degrees. This is a cubic polynomial. Oh, by the way, nothing past polynomials. Polynomials is the greatest thing. Largest number, just like how it gets to degrees, there's nothing after a polynomial. Are we clear?
Yes.
So now let's talk about these. Monomial, that's like this. It's just one term. Okay? Binomials like this. Okay? 2. Trinomial, 3 terms. Polynomial, 4. So you're looking at your operations in between and counting the terms. So look here. 1, 2, 3. There's 3 here, right? The exponent is, the highest degree is 3. So this one is cubic trinomial. Are we clear?
Yes.
So knowing the degrees, you figure out the degrees. You put them in standard form, you tell me what the leading coefficient is, and then you tell me what the terms are. These ones I think are easier. Let me explain. This has a little bit of an Italian descent. Ducatis, when they're a single seat, they call them monopostos. If it's bi or 2 seats, they call it biposto. Those words don't change. Bi means 2. Bicycle. How many wheels?
2.
Tricycle. How many wheels?
3.
Good. Does that help? Try. 3, bi, 2, mono. That's like a unicycle. How many wheels in a unicycle? 1. Mono. Poly, 4. Okay? Are we good?
Yes.
Okay, so let's go through a couple of these examples, then you guys can get started on your do now. So our degree is 1, right? Because we only have one exponent. This one's 0, this one's 1. What's the highest one? 1. So this is in standard form because it's in descending order, 1 to 0. We have two terms. How do we tell that we have two terms? Here's 1, subtraction, second term. Okay? So this is, our degree is 1, so this is linear. And then our terms are 2, binomial. So this is a linear binomial. Okay? So you want to know how to use this chart. You want to memorize this chart. You'll do enough of it. Okay, let's look at this one. First of all, how many terms do I have here? 3. Yeah. I have y2, y1, 4. Is this already in standard form?
Yes.
It is. It is. This one's 2, this one's 1, this is 0. There's 3 terms. 1, 2, 3. The degree is 2. The y2. Okay? So we go here. y2. 3 terms right here. So this is a quadratic trinomial. Okay? All right, let's look at the last one. 6x7, 9x2, minus x plus 3. In standard form, correct?
Yes.
It's going in descending order. You love these. You love these because it's 7th degree. You don't have to think about anything. Okay? So this one, there's 3 terms. How many wheels? Like a tricycle.
4.
Or excuse me, yeah. I was ignoring the 3. So four terms in here, 7, 2, 1, and 0 were 4 terms. We know we're a 7th degree polynomial. Okay? Nothing above polynomials. When you get to after 6th, you call it the number. 6th, 7th, 8th, and so on. Any questions?
No.
Okay, you need to know this chart, right? However you need to memorize it, do it. Constant, remember back to Algebra 1. A constant is a number. Linear, that's 1 term. Remember, there's no term here. That means there's no variable with this. It's just a number. This one has a variable with it. It's 1. Quadratic 2, that means to the power of 2. Cubic, power of 3. Power of 4, power of 5, and so on. 1 term, monomial. Binomial 2. Trinomial 3. Polynomial 4. Nothing higher than polynomial. Let's look at your do now. What degree is this? We're 2 and we're 1, right?
Yes.
So this is 3. How many terms are here?
2.
3?
It's 1. There's no addition or subtraction in this one.
Oh,
Yep. So this number, this is still all together. We're looking for addition or subtraction. Okay, Adrian? So this one is 2 and this is 3. So what is this thing called?
2 and 3, so it's a quadratic binomial.
Well, that's 2 and 3, right? So our degree here is what?
Cubic monomial.
3. We have to add the m.
Yeah, you mean the n is 1.
Yes, the m is 1. So if we're adding these together, 2 and 1, the degree is 3, correct?
Yeah.
Because it's all in 1 term. So if this is 3 and it's 1 term, it's 3, it's 1 term. So it's a cubic monomial. Are we clear? Isn't this one the same?
Yes.
Kind of. Kind of. It's to the power of 4, right? And there's 1, there's 5. Okay, so what I want you to do is I want you to find a degree, and then I want you to label them. What I would do is this. I would write this chart out on a separate sheet of paper, and I would have it on your desk the next 3 days. Okay? We're going to do enough problems. We don't have a whole lot of math except putting them in orders and counting degrees, right? Beyond that, then counting terms. It's not hard, but you have to know what these things are. If you don't, you're not going to pass this section. Which I know everyone can. That's why I'm telling you. However you need to remember it. The way I do it, Rubik's Cube, quadratic, I know it's x2, the line's flipping around. I know linear is 1 line. I know constant, no variables. I know 4 is quarters, and 5 is quin. Everything else is numbers. I know there's only 4 of these. How do I remember? Mono means 1, bi means 2, tri means 3, poly means 4. Okay? By the way, aren't the ends exactly the same on all of these? Someone say yes? Yeah, so if you can remember this, this is not that hard. It's just new to you. Okay? Is there any of this I need to go over again? Okay, flip over your notes for a minute. So you want to get the notes done, then I want to talk about the worksheet. You guys have I copied the vocab so you have it there. The only one that you're not going to do on this one is 13. Let me explain why you have two lines. The first line is for the degree. The second line is for the terms. Then underneath it, I want you to write what it is, okay? And that's on all of these. When you look at 4 through 6, you need to put those in standard form. Are we clear what standard form is?
Yeah.
Descending order of exponents, okay? That's all it is. I will give you kind of so you guys know, it's kind of a trick question. Let's say that we had this problem and we had this right here. Is that the first one? No, because we can solve that. We can simplify it before we ever got started. Is that clear? This isn't to a power. We know what that number is. So it's still a constant because we need to solve for it. Okay? It will happen. That will happen on the test. Okay, so pretty much the 4 through 6, you want to put those in standard form. Also, same thing on 7 through 9. Okay? So put them in standard form, tell me the degrees, tell me the terms, and then give me the name on all of them. Okay? But do the do now first. Okay? Are we good?
Good.
Okay.